Good morning to all. I'm Kubernetes from IT department, Sri Shanmuga College of Engineering and Technology. I'm going to take the topic DevOps Kubernetes. DevOps Kubernetes. It's the topic. Let's start the Kubernetes. In organizations, multiple number of containers run on multiple hosts at a time. So it becomes very hard to manage all the containers together. A simple solution to this would be Kubernetes. Kubernetes is an open source platform for managing containerized workload and services. That's why we switch over and we use the Kubernetes. And Kubernetes take care of scaling and failover for our application running the system. Next, this is the Kubernetes architecture. The Kubernetes architecture and the developer, and this is API server, control manager, scheduler, and etcd. So and here this is kubelet services, kube proxy, pod, and here itself kubelet services, kube proxy, and n number of Kubernetes can use. Here a set of users are also access the Kubernetes. Explanation. The master node communicates with worker nodes using Kube API server to Kube communication. In the worker node, there can be one or more pods to pods can contain one or more containers. Containers can be deployed using the image, also can be deployed externally by the user. Kubernetes architecture. So the Kubernetes architecture has it provide a flexible architecture for discovering services within a cluster while maintaining loose connections. Kubernetes cluster comprises a set of planes, compute nodes. The primary role of control plane is to oversee entire cluster exposed to API, manage scheduling of compute nodes according to the desired settings. The computer nodes run container runtime such as Docker alongside a communication agent called kubelet, which interacts with the control plane. These nodes can consist of physical servers, virtual machines, and on-premises for cloud environment. Kubernetes architecture. So this is the Kubernetes control plane, and it's the Kuber control manager and cloud control manager, Kube API server and Kube scheduler and etcd. So this is can access the space from cloud. So and this is Kubernetes nodes, kubelet and kube proxies. And API server in Kubernetes architecture, the API server is a key component of the Kubernetes control plane. It exposes the Kubernetes API, which allows users and other components interact with the cluster. The API server handles requests for creating, modifying, and deleting Kubernetes objectives, part services, and deployments. It validates the process. This request enforces authentication, authorization policies, and stores cluster state in etcd. And this is also the another architecture, mainly Kubernetes master present and Kubernetes nodes and Kubernetes node 6 also. And here the external users. Humans are automation tools that talk to cluster. Developers running Kubernetes apply and GitLab CI/CD pipeline doing Kubernetes rollout restart. Argo CD continuously syncing Git and Grafana dashboards with Kube state matrices. External customers hitting ingress service. And this is Cube API server. The only common front door validates every request, authenticates, users, authorizes with RBAC writes to every kubelet command in world hits this. All controller watch it. Admission webhooks interrupts request here. Custom dashboards, lens open lens, external API clients. It is the brain, the single force of truth, stores every object, stores every secret, holds these objects for leader election, stores all endpoint slices, keeps node heartbeat, and backups taken every 50 minutes by Valero. Cube scheduler. So generally the cube scheduler watches unscheduled pods, scores nodes, assigns node names, place high priority and critical pod first, respect node affinity, uses trains tolerations, balance CPU, and custom scheduler. So this is the function built by cube scheduler. So this is finally Cube Controller Manager. So Cube Control Manager runs 20 plus reconciliation loops and replica set controller. It maintains three replica of your app. And deployment controller does rolling updates. A namespace controller deletes everything when you delete a namespace. And certificate controller auto renews cert manager certificates. Endpoint slice controller updates service. Pod IP manage and cloud control manager. So talks to cloud provider APIs like AWS, Amazon Web Services, GCP, Google Cloud Platform, and Azure for load balancer, routes, and storage users. Create real AWS LB when service type, that is load balancer, and similarly provision CBS volume for PVCs. Update node addresses from cloud metadata and create GCP routes for services. Handle Azure disk attached detach and kubelet per node. Node agent stops containers and reports status, mount volumes, and run health checks. Starts your Nginx container, runs living scissors, mount config map, and apply resource limits, execute static pods. Then Q proxy per node, that is, it maintains IP tables and rules so service cluster IP works. So makes MySQL SQL, so default SVC cluster local reachable. Load balances traffic to 50 pod replicas and handle node port 3 3080 part 80. So works in IPv mode for 10K services. To support session affinity, sticky sessions, and container runtime. That is containerized CRUs. Actually, pulls images and run containers. So runs Docker Hub images. Support image full secret for private registries and enforces second app armor profiles. So garbage collects old images. Stream logos to journal Creo. Next, pods. It is the smallest unit. One plus container sharing network storage namespace. So main app plus Flinbit sidecar and web app plus Prometheus exporter sidecar and ISTO envoy proxy ingested automatically. In it, container that git clones, Corpus, ambassador adapted pattern for legacy apps. So next, CNI plugin. So it gives every pod its own IP and connects all nodes together. Calico, it network policy enforcement. Cilium, EBPF based L7 policies. Planner, so simple VXLAN overlay. AWS VPC, CNI, so multiple interfaces. So these are done by the CNI plugin tool and core DNS. It is a cluster DNS and resolves service names to cluster IPs. App connects to postgres.svc.cluster.local. External DNS create public root 53 records and Sky DNS compatibility for legacy apps. DNS based service discovery in microservices. Stop domains for an prim DNS. That means preliminary DNS. So Metric server. So collect CPU memory from kubelet, enables HPA, that is horizontal pod autoscaler. It scales deployment from 5 to 10 pods when CPU greater than 70%. Cluster autoscaler adds nodes when pods are pending. So kubelet top pods node works here and vertical pod autoscaler. Two types of autoscaler present here. One is HPA and another one is VPA. So VPA, vertical pod autoscaler, its recommendations generally coldly clocks tool for right sizing. So, and ingress controller, Nginx fake list to your gateway. So, like L7 HTTPS routing, TLS termination, canary header based routing. So, routes app.company.com. So, on terminates, let's encrypt certificates, rate limiting and authentication. Header, cookie based routing, global server load balancing with GKE ingress. And finally, monitoring add-on Prometheus Grafana staged metrics from everywhere. Alerts dashboards and alerts when pod restarts greater than 5. Grafana dashboard for golden signals and Prometheus operator plus service monitors. Thanos for long-term storage. an alert manager for Slack page duty. So, and this are already monitoring add-on tool. Mainly we are using Grafana. So, and this is the generally for Kubernetes it is also a container, and it's mainly used we access by using the AWS services. It's also, and it's I mean at a time in a single time we can access, we can use the system in a similar time. That's all. Thank you. Thank you.